Hello students, I am Dr. Tanmay Vishwash. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we are going to discuss about halogen acid and its important property. Mainly our focus will be HF. Okay, so two questions we are going to ask. One, fluorine is most electronegative atom, but why HF is the weakest acid among HCl, HBr, HF in water? Point number one. And second, HF is lightest, but why its boiling point is maximum compared to HCl, HBr, HF? Because we know that, let's understand the question first. Let's understand the question number second first. Then why HF is lightest but boiling point highest? Because we know that increasing molecular weight increases the boiling point. But in this case, boiling point is increasing, but all HCl, HBr, HI, they are gas. But this HF is fuming liquid. You can understand. Okay. So relatively higher. And second, about this, what is the meaning? Fluorine is most electronegative atom, but why HF is the weakest acid? Because if we say electronegativity definition of electronegativity is that the power to withdraw the electron density from a covalent bond. For example, if I look at HF, this is means HF, fluorine is most electronegative actually in Pauling scale. So what that is mean? It means that this bond pair is withdrawn towards fluorine. Okay, means fluorine is very happy to keep electron on itself. Means it like to form F minus like that. Okay, if you compare other HCl, HBr, and HI, compared to them, this is most electronegative. So if most electronegative, then it is expected that this HF bond should be broken very easily. Sorry. This HF bond should be broken very easily, but in reality, why it is not happening? That is the question. First, see, this is actually a covalent bond. This HF is a covalent bond, and this covalent, actually I agree there is a polarity, but this is a covalent bond, and this is a very strong covalent bond. Why? Because of proper orbital overlap. Please keep this word in your mind. It's a very proper orbital overlap. Why I am saying this? Because hydrogen is the first row element. Okay, everything. Fluorine is the second row element. Chlorine is a third row element. Bromine is a fourth row, fifth row. So when you are coming down according to periodic table, the size increases. If the size of this atom increases gradually, then extent of overlap decreases. So if overlap is less, the bond is automatically weak. So if the bond is weak, then it is easy to dissociate, and dissociate means H plus and corresponding X minus X means halogen. Formation is easy. So bond dissociation is minimum in case of HF is the strongest acid. Simplest. But in this case, this is not that much strong because this is actually covalent bond is stronger. Another thing, I have given another word in water. So this is about in water. But there is an exceptional property of HF that in concentrated solution it's a very strong acid because it's different ionization. I shall discuss in a previous video. I shall provide the link. So from that you understood the answer of this question. So HF is lightest, but its boiling point is maximum. Then is why? Because HF is also lightest, but it can form hydrogen bonding, very efficient hydrogen bonding. We know that foreign element, fluorine, oxygen, nitrogen, can form very strong hydrogen bonding. There are some exceptional example like chloral to chloral hybrid, where we can observe chlorine is forming stable hydrogen bonding, but others doesn't form that much stable hydrogen bonding. So what happens in case of HF? If you look at this, HF molecule can form hydrogen bonding very efficiently. Okay, means another hydrogen. So in this way, another fluorine. So in this way, this chain wise they can form hydrogen bonding, and this is a very strong hydrogen bonding. So through hydrogen bonding, what they provide? They provide a chain-like structure, chain-like, zigzag chain-like. You can another thing you can say it's a polymeric type entity. Polymeric type. I am not saying hydrogen polymer. Don't get confused. Polymeric type means different monomer by individual entity are joined together and produce a large entity. In this case, normal polymer, that's a covalent bond, but in this case, weak means hydrogen bond is generally weak, and among all the weak hydrogen bond, this fluorine hydrogen bond is the strongest, so relatively stronger hydrogen bond. So now if you want to make it is in liquid state, so if you want to make it liquid from gas, what you have to do, you have to break all these hydrogen bondings, and for that you need to put more energy, and for that purpose the boiling point of hydrogen fluoride gets relatively higher. But in this case only you can see that in all these cases what is the difference, because this chlorine, bromine, iodine molecular weight increases, but that is not that much significant like this hydrogen bonding. That's why although molecular weight increases, they remain in gas form. Okay, so this is the overall discussion. I believe you have understood two properties of this. So thank you again. Stay happy, stay blessed. See you in my next video.